Anyone recognize that tune? It's a kind of magic. That's pretty much what most people think about geolocation. It's a kind of magic. And they're also expecting magic as well. Unfortunately, magic's not real. We need to create some reality. And hopefully, I can give you a little bit of an update on where we are in our magician status. And some of the new cloud services, they're going to be coming and just give you a flavor of where we're heading. Going back to Alistair's presentation, first thing this morning, we all woke up, and he had two messages, focus and simplify. We need to focus, really focus on the needs of the application. We need to focus on simplifying everything, simplifying how we get to market, take complicated issues and problems and boil them down into simple solutions. So my cloud services are all about taking something which may be quite complex, quite awkward or difficult, and turning it into an API. You just send the stuff and get an answer. So really picking up, driving on what Alistair was saying there. So what's the vision for my group? We're starting off, most of you have probably come across geolocation. Nicolas mentioned in his talk yesterday that there's going to be some soft modems coming, and for each of the things that we drive out, integrating into the device, there's got to be another end to that thing. So we will be putting together services and rolling them out to match the rollouts that we have in the hardware and the firmware on the device. We will be able to match those with things in the cloud. Nicolas also mentioned join server. Security is a big thing. We know that it's something that people love to argue about. There's things that are good and things that are not as good enough. We all know that security needs to be nailed up and just a given. LoRaWAN, secured, done. So we need to make sure we offer a simple solution to that. So we're going to abstract these things, whether it's locating your stuff, whether it's just getting it connected, or full lifecycle management. We're going to extract it into simple API calls that you can stitch into any service. So let's look a little bit closer at geolocation. This is a slide we looked at last year. We just threw a few technologies. There's more than this. But they've all got their pluses and their minuses. You know, GPS, we think it's a kind of magic. We love GPS because it gives us a blue dot on our phone, although a lot of the time, the blue dot on our phone is not coming from GPS. We've got beacon solutions, we've got cellular-based solutions, we've got Wi-Fi, we've got LoRaWAN. All of these things we love to love, we love to hate. One way or another, they don't actually cut it on their own for most applications. And let's look at an example. This is from last year. For those of you that were last year, I'd lost my iPad. So what did I do? I said, where was I? Probably at home, in the office, or in the pub. So I go on, find my iPhone. My iPad is somewhere in all of these houses, right there. I better get a search team. I've got a lot of houses to look for my iPad. We've got something known as metadata, something a little bit more than the data that's actually coming from the device, which is, I know where I was. I kind of remember. So what do? I have to go on to find my iPhone, and what do? We make it make a noise. So we're completely au fait with the fact that we've now hybrided two location technologies. Making a noise saying, hello, is a location technology. You located me from my noise. And so is our iPad going do-do-do-do, like our keyring back in the 1980s. There's some people here too young to remember the 1980s. But those of us that had a keyring, there you had it. So we've lived with that for decades. Why do we expect magic? So, GPS wasn't working in my house. Cell triangulation wasn't working in my house. It might have used my Wi-Fi. I don't know. I don't care. I just know that I had to make it make a noise. So we're okay with that as a concept. So this is my mantra. Make the solution meet the needs of the application. Don't overcook it. Don't overbake it. Don't overcomplicate it. And understand that if you need to know when a device is on this particular shelf in this particular alley, do you always need to know that? Do you need to know it once and know that it didn't move? Do you need to know 30-centimeter accuracy when it's in a truck crossing the country? Probably not. When we provide a location solution, we don't know what that device is. We don't know what it's trying to achieve, and we don't know the application it's in. However, you might if it's your device. So your application needs to meet the needs, and we need to be realistic because we haven't got unlimited time on air, unlimited connectivity, and unlimited resources to throw at it. So, everything you need, nothing you don't. We talked a little bit about this last year as well. Why would I put a GPS on my dog collar? Because GPS is a kind of magic. We've learned that already. I've said that several times. But GPS is not magic. It doesn't work in my house. The dog spends 95% of its time in my house. So I'm going to build a Wi-Fi sniffer into my dog collar, and I'm going to sniff my home Wi-Fi, and I know if my dog is home or not. I could use the sound thing. Dog, woof! The sound thing comes back. I've found my dog. So I could use Wi-Fi, but the Wi-Fi isn't going to work when I'm in the woods. So comprehensive geolocation to meet the application is inherently hybrid. You can't get away from it. We can try, but we can only meet a small proportion of the applications until we understand we have to make a hybrid of those different technologies. We can't select a single technology. We've got to build intelligence into the device. Just a little bit of critical intelligence, just a little bit that it can respond to triggers and respond to fences of whether it's a pressure fence, a temperature fence, a light fence, a vibration sense. Something's happened to the device to trigger it into a different mode. So what's happened over the past year? I'm going to shout out to a few of my friends here. KPN launched their location service. We had a whole paper on that this morning. Very interesting. I love this story. I love a lot of stories in LoRaWAN, but the VLOC guys love this story too because they found a massive digger. How do you hide a massive digger? You put it behind your garden fence. Hidden. Done. Job done. But these guys found it because they put their device on a digger, and because it's battery powered, they can fit it anywhere. They don't know where it is. It might be under the wheel arch, it might be under the thing, it's not connected to the battery. All good. KPN, pretty happy. VLOC, pretty happy. Digger guy, happy. Obgenius, they launched in France with a nationwide network. There's some data taken from a paper they've released where they've checked this. They've got a truck going right across the country, logistics for big construction. They look at it in downtown Paris. It's essentially doing what they need to do for quite a number of applications. It's real, it's up there, it's working. The proof of the pudding, as we say, is in the locating. Smart parks, they got a paper, I think, last up this afternoon, or second to last up. We all love this story. Like I said, I love all these stories, that's why they're in here. Rhinos, you take a rhino, sedate it, drill a hole in his horn, and put a LoRaWAN sensor in there. They put gateways on the hilltops. They're 10 kilometers apart. They cover 80 square kilometers with 4 gateways. And now they start locating rhinos within 25 meters on average. They can, for 50 euros per animal, they can get 7-minute updates for 2 years. If they wind the update rate up, they can start seeing behavioral patterns in the animals. This is a really good story that really is changing things out there. We launched our preview location service last year, Collos. The users carry on growing. They keep on signing up every day. It showed me that there's a very clear appetite for a free-to-use geolocation service. And in that service, we had to prove Semtech as a chip company, can we run a cloud service? We've had 0 downtime. We've had some very, very good feedback from folk where they've collected 3 months worth of their data, thrown it at the service, and it's come back, resolved every packet in a couple of hours. So we're very happy with that, and we're taking that to the next level. We've been using that in Grenoble. These are some of our own tests. So I think about different types of location. We talk one shot, and we talk what we call multi-frame. One shot is one packet, one uplink, received by multiple gateways, send it out there, get a location back. So if you're static and you do that with every packet, there's an error on every packet, and the location moves around. This is a typical packet with a device that I have here. This is a PyCom LowPy. Great development device. You just load a Python script into it. This is listening to the Wi-Fi access points and uplinks them via the LoRa. We push this through the Collos platform. We've put it through 8 location solutions. A signal strength-based one, time of arrival-based one. Then we say we're going to use also Google Wi-Fi lookup. We're going to use Skyhook Wi-Fi lookup, Combane and Unwired Labs. Then we have a multi-frame. That is where we take multiple uplinks, bundle them together, and let the algorithms work on them. This is only a 1 packet, so the multi-frame doesn't give us any different results to the single frame. So on this particular packet, we've got around 400-meter inaccuracy on the signal strength, 120 or so on the time of arrival, and the Wi-Fi vendors there you can see in the sort of 20 to 40-meter range. What happens if we send multiple packets? So this is 4 packets. If with each packet we locate, and we take the centroid of each of those and boil them down, we get the average error. So 4 packets, time of arrival, shows us an average of around 120 meters. But if we bundle them together, because we are comparing gateway A versus B, B versus C, C versus D, if we take each one of those gateway reception pairs from 4 packets and bundle them all together, then we can start throwing away and discarding data and getting a much more powerful processing result. Here we see not a huge improvement on the RSSI. It always improves, but to a variable amount. It never gets worse. Here you see an amazing improvement if we happen to have 16 packets. The signal strength one here, don't expect this all the time, but it just happens to have gone to 50 meters, and it was the average error on this one was around 400 meters. But you can actually see here, we start, after we get a number of packets from a single location, we start to get close to what we're getting with the Wi-Fi. And it's one thing that I've seen with most of the data is there's not a huge difference between one Wi-Fi lookup vendor and another. They sort of do this in their error. Let's go back to our PyCom device here and say, what can we realistically do? How can we make this application do something real and push some intelligence into the device, just a little intelligence, but critical intelligence into the device, and pair that with some other intelligence in our cloud solution? So given that we're in Amsterdam, there's only 3 things we can look at. One of them is smoking, obviously. One's bikes, and let's leave it there. So this is a bicycle tracker we're going to make. We're going to cycle to work. We get on our bike at 7:30. We cycle till 8:15. The bike sits there. At 12, we cycle to the sandwich store. 10 minutes, have something to eat. We cycle back. We cycle back home. So there's 4 events, or 4 trips in the day on our bicycle. So I'm going to turn this into a bicycle tracker. The first questions we say, do we need to track the ride or just where the bike is? What technologies are we going to use? And how long the battery life and all of those kinds of things. So we have a little discussion. We come up with what we think we're going to do. And we say, let's build our prototype spec. And this is my very simple spec. We care mostly about the location when it's stopped. Because either the bike is where we left it, or the bike is where someone else left it, kindly. So we don't care so much because our Garmin's going to tell us how we did when we were cycling it. We also wish to respect VTN's fair usage for time on air, which is around 30 seconds per day on air. And we need to be accurate to building level because either the bike's where we left it, we just need that little reminder, or we're going to go looking for it. We could in that if we want to, but that's where we're going to start. So on here, I've got my movement detector. I'm going to detect movement, and I'm going to detect stopping. And I'm going to use some kind of best effort. How can I best get a location result when I stop? I'm not so concerned about tracking the path, so I may or may not send packets when I'm moving, depending on how it comes out when I minimize the power. And I want to minimize the power and the time on air so if I just stop moving, I don't really need to send any packets. But we all like to know our device is still alive. So we'll send a packet every now and then, maybe every hour, 2 hours, 3 hours. Doesn't matter. But I want to maximize the coverage, so I don't know where I've stopped. Am I in a great spot? I have loads of gateways. Do I only have one gateway? So what intelligence am I now going to push into this device? There's this accelerometer on here, so every time I move, I'm going to reset a counter. It's pretty straightforward. Every time I uplink a packet, I'm going to increment that counter. So what does that tell us? 1 byte in my payload tells me how many packets are received from this device right here. So I can now look at the frame count and say, the frame count is 457. I've had 3 packets in this location, so I can take from 457, 456, 455. Any of those packets I've received, I can bundle them into the multi-frame. So we can now simply transfer that small amount of intelligence back into the cloud to do a multi-frame that's completely appropriate to the position we're in. I'm going to detect when I'm static, and I'm just going to say, well, let's wait 5 minutes, because I might have stopped to talk to a buddy or whatever, but if I've stopped for 5 minutes, I'm going to send some packets. Then I'm going to send a burst of packets, because we know from those results our best shot at getting an accurate result from LoRaWAN, should we be out of Wi-Fi, is to have multiple packets from the same endpoint. So that's very simple intelligence we push into the device. As I mentioned, in the cloud, we leverage the uplink counter. So all the packets that get sent from the same location get sent to the multi-frame endpoint. It's as simple as that. If I go back to the device, I can use MAC address compression. So first thing I'm doing here is, when I fire this up in here, I see 88 access points. 88 access points. Which ones mean something? Which ones are you guys with your iPhones going to completely mess up my location? So number one, I'm going to filter out everything I know that ever came from an Apple device, or a Samsung, or an HTC. Number two, I'm going to compare MAC addresses and say, these sysids appear to be coming from the same piece of hardware because they have a similar MAC address. So I build myself a list of what I think is unique hardware that's not a phone or a tablet. And it's really simple, and it can be done in here. And then we can compress the MAC addresses, because now we've got LoRa as a location. We can find in our database the Wi-Fi access points with those compressed MAC addresses that meet that location. Even if there's some that meet that compressed MAC address, they're in different places in the world, they don't appear together in the same place. So we can augment this, of course, with commands. We can tell the device to do more or less, but essentially, let's leave it at that. So let's look at an assessment of time on air. Time on air equals battery. So it's obviously, it affects capacity, it affects our battery life, etc. So what if we transmit every hour when we're static? If we have Wi-Fi address compression, our time on air is 14 seconds. Without Wi-Fi address, 14 seconds. Because we're actually not doing enough, not uplinking enough access points to make a difference to the time on air. If we go down to 2.5 hours when we're static, with 1 minute tracking, so if we transmit a packet every minute, we go between 14 and 16. So in this example, where our device is only moving 4 times a day, there's not a huge difference between sending what is a compressed MAC address, which is half of the size, and if we don't. But what happens when you've got a guy who's cycling 6 times a day, or if it's in your bag, and you keep getting your bag up and moving it? Then we start to see a 10, 15, 20% difference by using compressed MAC addresses are not. So if we look here at 1 minute tracking with 2.5 hours between it, we get 32 seconds time on air for these 6 movements versus 25. It's a 20% improvement. So we have to think, where are our advantages? What's important? Do we care? What's the application? Is this a bicycle? Is this a bag? Is this something? Just make it appropriate and push very simple decision-making into the device and match it with something in the cloud that understands. And we can, just using that single byte counter, we can really make a huge difference. So, where next for the cloud services? We mentioned this a little bit earlier. I'm going to come back to stealing Alice's slide. Focus and simplify. We're going to help you guys make it simpler. We're going to take awkward problems and push them into an API you can just push to us. We will also document how we do that. So if you want to make your own, you can. Knock yourself out. It's not going to be something that we're going to force you into. There's going to be no tie-in. We're going to help to ease, simplify, and get focused, in my case, on the application. So, abstracting complexity into simple APIs, we start with location. We're going to be doing things to support our modem and our device management. And, of course, there's the security so that we can onboard, offboard, and full lifecycle management of devices. And that, pretty much, folks, is me done, allowing 6 minutes for any questions.
As well, thank you very much, Richard Lansdowne.
Thank you.